Assalamualaikum everyone, myself Dr. Mamoona Azhar, physiotherapist, and today I'm going to deliver a lecture on the subject of medical physics, and the topic which I'm going to give a lecture and discuss today is it's all about electromagnets. In the recent curriculum, like the curriculum which was before the updated version, in that electromagnets were being the part of the topic in detail. But after that updation of the version of the curriculum, the topic is not important to study, but still we are going to have the information about the electromagnets, because sometimes the things comes from the out of the syllabus and it might be difficult for you to cover these questions if these questions are included in the syllabus and in your papers. And also it is important for you guys to learn that, because electromagnets consist of very important two topics, voltmeter and ammeter, and its MCQs are really important in practical. So I hope you guys will understand the lecture easily, because it's not a difficult lecture. So we are going to start with electromagnets. What is electromagnet? Electromagnet is a type of magnet or electromagnet which is consisting of a coil of a wire or a wire of a coil which is being grabbed on iron. For example, this is the iron and a coil of wire, a wire of coil is wrapped over it. Now when the wire is wrapped over this iron piece, what will happen if you give current to that iron piece, if you give current to that wire, the magnetic field will automatically be produced from that wire, because we have studied in the phenomena that electric current produce magnetic field, and the magnetic field is being produced when, for example, this is the soft iron core around which you can say that it's a wire which is covering it, which is giving it a covering. Now you are giving potential, you are giving the current. What will happen? The magnetic field will be set up in this region, and when the magnetic field will be set up in this region, the iron would automatically be magnetized. Now why did we use iron in this place? Because it is really easy to magnetize and demagnetize iron. So iron is the best equipment in electromagnet, because we want to magnetize the equipment with help of current, so it can be magnetized really easily. And it also depends upon the intensity of the current, that if the intensity of the current is higher, automatically the strong magnetic field would be produced, and if the intensity of current is lower, the weaker magnetic field would be produced. Now we are going to study about ammeter. The next topic we will study is the moving coil milliammeter. It is a part of electromagnet, and first of all we will learn about what is ammeter. Ammeter is a type of electromagnet, or is a type of equipment which helps to measure the intensity of the current. And how it helps to measure the intensity of the current, and how and at what principle it works? It works on the principle of magnetic field of electric current. So the principle you guys need to remember for this is the magnetic field of electric current. There are many equipments which can help us identify the intensity of electric current, but the best equipment in electromedical apparatus which is being used in these days and it is in the practice, it is moving coil milliammeter. And the working of moving coil milliammeter can be shown with the help of a diagram. Let me just draw it and you guys will be clear about this. For example, there are two permanent magnets, North Pole, South Pole. These two poles are being generated as there are two permanent magnets, and a pivot is present here. A pivot is the point at which it is the place, it is the pivot point which is kept in between the permanent magnets, and it is being covered with the wire. And the name of that wire is solenoid. 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 You cannot see that directly because I am opening the front camera, so you can get it spelling from the book that it's the wire of the solenoid. Now the wire is being attached, and there is, you can see that we can apply current out here. When we turn on the current at this resting place, these are two permanent magnets, and at the resting place the pivot point is being present at the right angle to both of the magnets. For example, these two are present like this, and at the right angle pivot is placed. But when you turn on the current, the solenoid gets the current. What will happen after that? As you guys know that the magnetic field is being produced from that electric current, so its own magnetic field will be produced in the solenoid region, and it will attract and repel those permanent magnets. At some point, when the north comes toward this region and south comes toward this region, they both will start repelling each other. And at the point when the south comes towards this region and north comes toward this region of its own magnetic field of the solenoid, then they will start attracting each other. And how this pivot is being pinned with the wire? It is being pinned with the hairspring. You can name it by the hairspring. So hairspring is the point which is attaching it with the place and with the pivot. Now one more thing to remember is it is only used for the direct current. It is not used for the alternating current. Why it is used for the direct current and why it is not being used for the alternating current? There is a very important concern regarding that. Direct current is the current which is having the single polarity, and it is just going in the way that there is just a single wave, and it is really easy for the ammeter to do that and measure the intensity. After this question, I will tell you a bit more thing that how it acts like ammeter. The second thing, why it does not imply on the, or it cannot be applied on the alternating current. The answer is the alternating current reverses its polarity. Now it is a neutral line, and it is upper polarity, lower polarity, upper polarity, lower polarity. Now when the polarity is being reversed in the positive and the negative, the polarity is reversing so fast in the alternating current that the wire and the current cannot even be able to detect the magnetic field itself. So magnetic field is not being generated so quickly because upper polarity, or you can say the positive polarity, the current is trying to have the magnetic field, and within the second the polarity is being reversed and current try to again form the magnetic field, but it will not be able to form because polarity is reversing so quickly. And another thing to tell about that, how it can measure the intensity of the current. A needle is being placed over it. When there is high intensity, obviously there would be a strong magnetic field, and when there would be strong magnetic field, the needle will deflect. So the deflection of the needle will let us know about the strength of the magnetic field. Now you guys are clear about the ammeter. One last thing to remember about the ammeter is it has the coil with few turns of large wire. Its coil is having the few turns, but its wire is really large. So this is the point you guys need to remember, that it measures the intensity of the current. It has a large wire with less turns of the coil, and permanent magnet is being present on the side, and it is working in this way. And if you are using the direct current, it is really easy to measure the intensity with the help of ammeter. But if there is interruption in direct current itself, there would be fluctuation in the current, and when fluctuation would come, the pivot and the wire will have to and fro, and the needle will also act in that way, that to and fro motion, and that to and fro motion will lead in the damage in the hairspring, and when the hairspring will be damaged, your circuit will not be able to proceed further. So now we are moving towards our next topic, which is about the voltmeter. What is the voltmeter? What is the purpose of the voltmeter? What is the construction of the voltmeter, and how it can be used in our practical lives, and what is the principle of the voltmeter? So what is voltmeter? Voltmeter is a device, is a meter which can help us measure the potential difference of the current. As the ammeter was telling us about the intensity of the current, the voltmeter will tell us about the potential difference of the current. And one more thing to remember is it has the coil with many turns of small wire. Small wire, many turns. Just opposite to ammeter. Voltmeter is just opposite to ammeter in this turn, in this manner. So the voltmeter can measure the potential difference between 2 points, and it works on the Ohm's law. As you guys all know that what is Ohm's law? V is equal to IR, and when V is equal to IR, I is equal to E over R. Can you guys see that easily? I is equal to ER. No, sorry. I is equal to E over R. V is equal to IR and I is equal to E over R. Now, we know that it can measure the potential difference. At this point, according to Ohm's law, I is equal to E over R. If the total resistance of the meter is 1000 ohm, a potential difference of 1 volt between the terminal will produce the current of 1 milliampere. Now what is the meaning of this line? If we are having the 1000 of the resistance and having 1 volt of current, 1 volt of potential difference, the current we will have at this point is 1 milliampere. Did you guys notice that? 1000 resistance, 1 volt of potential difference. So the current we will have, it will be 1 milliampere. And if you guys can see that, if we change the potential difference to 2 volt, if it becomes 2 volt, it would become 2 milliampere. It becomes 3 volt, it becomes 3 milliampere. It becomes 4 volt, it becomes 4 milliampere. And in the same way, if we change the resistance, if we are having the resistance of 8000, for making the current of 1 milliampere, we need to have 8 volt. Now, if we change the resistance in the same way, we need to change our potential difference just to have 1 milliampere of the current. So it will be really easy for us to get 1 milliampere just by fluctuating the resistance and by fluctuating the other part, which is called potential difference. Another point which is being mentioned here, that many voltmeters are provided with alternative resistance to allow greater range of EMF. Alternating current is being provided to the voltmeter just for having the greater range of EMF. At the end of this lecture, I will tell you a bit how alternating current was being used in this kind of equipment and why it was not being used in that kind of equipment which we have studied already, and that was ammeter. Wiring in the circuit. The purpose of the voltmeter is to measure the potential difference between 2 points. We are clear with that. So it is connected to these 2 points in parallel to any circuit that may exist between them. Let me just draw it for you so you guys can easily learn that. The point we just mentioned here, that the voltmeter should be kept in between 2 circuits. And the reason will be mentioned why 2 circuits and how it will affect them. As you guys can see that there are 2 circuits. When there are 2 parallel circuits placed parallelly with each other, what will happen? In parallel circuits, the potential difference would remain same. When there are 2 parallel circuits placed together, they would have the equal potential difference. Their potential difference will not change. But if they would be in series, their potential difference will automatically be changed. So for voltmeter, we will have the parallel circuits. And another reason for that, the addition of the parallel pathways to the circuit causes a decrease in resistance and increase in total intensity. Another reason why it is being used in the parallel circuit, it causes decrease in resistance and increase in intensity. So it can be remembered really easily that why we use parallel circuit in the voltmeter and what are its advantages and disadvantages. And therefore the voltmeter has high resistance. Otherwise its inclusion may cause a marked increase in total intensity of the current. So when voltmeter is being used in such devices, when there are parallel connections, we need to maintain a high resistance, because when there is not a high resistance, because total resistance would be low and intensity would be higher, and at that point if the resistance is not higher, we will not be able to maintain that high intensity and the low resistance. One last point which I just said, that how we can use alternating current and in such equipments. The moving coil meter is suitable for use only with DC. DC is best when it is not even interrupted. It is the best current which can be used in these equipments. But with advent of the new knowledge and with the application or presence of the alternating current, it was being considered that how can we use alternating current. For usage of alternating current, we can convert the alternating current into direct current with the help of a meter, and that meter which is giving the direct current, we will use that converted direct current into our equipments. So this is the way we can use the alternating currents for our equipments, for measuring the potential difference and for also measuring the intensity of the current. So I hope you guys are clear about the lecture, and if you have any query or any question regarding that, you can ask me directly, you can comment. And one more thing I want to add for you, that we just have studied 3 chapters yet, and the chapters which are left for the whole book is 7. I just thought that after the summer vacations we will be having we will not be having online lectures, and you guys will come to college and we will cover the syllabus really easily. But now I am understanding that we are not having much time to cover 7 chapters. We are having around 5 months to cover 7 chapters. So we need to be really quick, and by the completion of any chapter, I will take a viva and a test from you guys, and meanwhile during the lectures I can also voice call you or face call you, or I can WhatsApp you guys with video call, for having an idea that you guys are clear about your book, about your chapters, and you are studying really positively in this quarantine, and it's really easy for you to cope up with all the situation you are facing these days. So I wish all of you guys the best of luck for your future and for also your present time. Thank you so much.